Welcome, my students. Our today's topic is thermal phenomena and expansion of the matters. I know there are so many effects of heat. When heat is absorbed by a body, its temperature may be increased by absorption of heat. Temperature may be increased. Number one, temperature increases. Number two, change of state occurs. Number three, expansion or contraction. So, there are so many effects of heat. On absorption of heat, temperature may be increased, and extraction of heat, temperature may be decreased. This is called, I think, sensible heat. And when the temperature increases, state remains unchanged. But after attaining a particular temperature, say water, attaining 100 degrees Celsius, it starts boiling. But not only attaining 100 degrees Celsius boiling occurs, water will take certain quantity of heat which is latent, which is hidden, and that heat helps to change the state, that is boiling of water. This heat is called latent heat. So when state changes, temperature does not change, and when temperature changes, state is not changed. Moreover, there is a third effect of heat. When heat is given to a solid, to a liquid, or to a gas, it may be expanded in volume, and in case of solid, may be expanded in length, in area, etc. A solid body will be expanded on heating. Its length may be expanded, and with the increment of length, its area will also be expanded, and its volume will also be expanded. But in case of liquid and gases, only the volume will be expanded, because the question of length and area of liquid and gas does not arise. Now, our topic is linear expansion. On heating, a solid body is expanded. First, linear expansion, that is length expansion. If you supply heat to a solid body, say its length is L, then some expansion of the solid takes place. Say the initial length was L1. Instead of L, I take L1, and after expansion, it becomes L2. So the expansion is expansion equal to L2 minus L1. And say a temperature of T degree is increased. For T degree increment, expansion is L2 minus L1. Now, for 1 degree increment, expansion L2 minus L1 by T. And this expansion takes place for a solid of length L1. Therefore, for unit length and for unit degree rise of temperature, expansion is L2 minus L1 divided by T degree into L1. So, the formula of linear expansion is final expansion minus initial expansion divided by initial length into temperature increment, L2 minus L1 by L1 into T degree. This is called linear expansion coefficient. Linear expansion coefficient. Therefore, linear expansion coefficient of a solid is defined as the increment of length of the solid per unit length or unit rise of temperature. And it is expressed by the function L2 minus L1 by T into L1. It is called alpha. Linear expansion coefficient is expressed by a letter alpha. Alpha equal to L2 minus L1 by T into L1. Now, what will be the unit of linear expansion coefficient? L2 minus L1, it is the unit of length, say in SI unit of linear expansion, SI unit of alpha. Unit of length meter divided by T degree, unit of temperature, in SI it is Kelvin, into initial length meter. So meter cancel, that is equal to 1 by K or K inverse. So Kelvin inverse is the SI unit of linear expansion coefficient. Similarly, in CGS, it will be degree Celsius inverse. Keep in your mind that before Kelvin, no degree is written. So Kelvin inverse and degree Celsius inverse are the SI and CGS units of linear expansion coefficient respectively. So this is about linear expansion coefficient, and the linear expansion is seen in so many phenomena in our daily life. Say a bottle mouth has been sticked with the bottle, and if you hit the bottle, mouth of the bottle, when the mouth of the bottle gets heated, it is expanded, and then it will be very convenient to open the bottle mouth from the bottle. It is an example of linear expansion. And similarly, linear expansion is seen in case of rail lines. At the junction of two rail lines, a gap is kept. What is the reason behind keeping this gap? Because when the line gets heated for friction and sunlight, then it will be expanded. So there is a possibility of a collision between the two lines and it may be broken. So for expansion, a gap is kept so that it may be expanded on heating. It is also one of the phenomena of expansion or linear expansion. We have completed linear expansion. Now we will go through the superficial expansion or area expansion. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.